Hello and welcome to CS200. This is a review session for Chapter 9 where we'll be talking about objects and classes. We're going to follow zyBooks Chapter 9 and we're going to be talking about objects at a level that's more like a review as opposed to covering new material. Now with objects, there's a paradigm shift for those who have been doing mainly procedural programming, where we have just a bunch of variables that don't have any kind of cohesion. And in this case, we're going to talk about objects. And objects are, in many cases, nouns. And what this is it allows us to group data that reflects about a particular object or something that's interesting to us in the program. So the example that they give here in zyBooks is a chair. Now, it's got attributes, which are ways in which we can describe that particular chair. So these might be the color, maybe the material it's made out of, the manufacture date, the manufacturer. And it also might involve different things we can do with that chair, such as sit on it or lie down. Or it could be something more meaningful like getting the serial number for the chair, assuming it has one. So this grouping of data and variables as well as the operations, which are the methods, are the two principal components of an object. One of the benefits this gives us is the ability to do information hiding. Let's just say we have a driver's license as an object. Now it has a driver's license number. It probably has the driver's address. It may have a link to the different kinds of infractions that driver has been involved with. We want to be able to control access to this information. So we have something called encapsulation or information hiding. So the outside world doesn't need to know about the infractions this driver has, or they shouldn't be able to change the driver's license number. Only specified individuals, meaning the DMV or the police or maybe the court system, has access to these items. So if we consider a driver's license as an object, we have information that we can read easily, perhaps the driver's license number, and other information that we want to keep hidden. But we don't want to have the driver's license number be able to be changed by anyone. So we have a way of hiding this information and only showing it to who is an appropriate requester. So we've already used classes, and the class construct is a type that we can group data and methods to form an object. So a public member method is an operation that a class user can perform on that object. We don't need to know all the details about what's going on inside that object. We just have to have a way to access what we need and have the permission to do it. So if I go through this example here, first of all, we have a class called restaurant. Notice the capital R. It's not required, but by convention, we use capital letters to start a class name. Then we have a set name, set rating, and print. These are three methods inside of that class. And notice they have public void. So we know they're not going to return anything, and they have public access. If we change this to private or protected instead of public, this would change the ability for access. But we're talking about public classes here, so that's why you see the public as the start of each of the signatures for these three methods. So we see here from the example, we can set the name, we pass it a restaurant name as a string. We can set the rating, we pass it a user rating as an integer. And then when we print it out, we get some kind of output which has that information. We haven't defined what is in each of these yet, but we certainly will. This is just describing how we get access to that. Notice I don't have the ability to go into restaurant and set a variable with that name. I have to use this method called setName to do that, and also with rating. So how do we define a class? Well, we define a class with public class and then the name of the class. And then inside of our main, if you look here, we have restaurant, and remember that's part of this class that we've defined up here, where we have restaurant, and we have a couple of methods involved with that. So we declare restaurant, and then we give it a specific name. In this case, it's favorite lunch place equals new restaurant, and then we have parentheses here. So this is creating a new object called restaurant, and we're calling it Fave Lunch Place. We do the same thing here, and then we can refer to each of those objects, Fave Lunch Place and Favorite Dinner Place, separately, and we can give it specific information. Now there's two objects created, both of type restaurant, and one is called Fav Lunch Place, the other one's called Fav Dinner Place. And each of those have different properties. We can see that Fav Lunch Place has a name called Central Deli and a rating of 4, and Fav Dinner Place has Friends Cafe and a rating of 5. So there's a number of public member methods that we've used, especially when we were working with strings. So we have char at, which takes an index into an object, which is a string. We have another way to look at the length of a string, and that's also going to return an integer. We have the ability to concatenate strings. You can see that it's going to take a string as a parameter, and then it's also going to return a string. So we've talked about public member methods. We also have private fields, which are variables that member methods can access, but a user outside of that particular member method cannot. So we would do something called private. We would declare each of these variables inside of the class, but outside of the method. And we have private string name, private int rating. And because of that, if I was outside of this particular class, restaurant, in other words, outside that code, and I tried to access these or change them by saying restaurant.name equals another name, it's not going to work. It's going to give us an error. So here's an implementation that shows how we can print out the values. And you can see favlunchplace.print and favdinnerplace.print give us a different answer because they have different attributes associated with each of those two objects. So there's two kinds of methods that we normally see associated with a particular class. There's two types of methods that we commonly see associated with an object. One is called a mutator. Mutate means modify or change. An accessor means to access. So typically we call them setters and getters. The setters are the mutators because it's setting or changing the value, and getters are the accessors because it's retrieving information. You'll see these types of mutators and accessors used commonly with objects that we'll talk about in this course. So with restaurant, you can see that we have a set name, a set rating, and we have a get name and a get rating. So what we often see is that we have a void when we have a set because we're putting information in or changing information with that object. And we're not returning anything. You can see that we have a parameter called restaurant name that we're passing in, and we're returning nothing. With the accessor methods, it's the opposite. We're not passing anything in, we're returning whatever the data type of that particular attribute is. So you can see the same thing with get rating. It's going to return an integer. And then with print, it doesn't return anything. It's just going to take an action. So it doesn't pass anything in, and it doesn't retrieve anything. But we call these accessors anyway, even though they don't have get in front. So you can see this class called myRestaurant is actually using restaurant and creating a new restaurant. So let's take a look at that inside of BlueJ. So first I've got restaurant plus a couple of other things. We'll talk about constructors here in a minute. But you can see I've got all these items here that are getters and setters. And you can see I've got a different print statement, but it still does the same thing. And in BlueJ, you can see there's this dashed arrow. And this is from restaurant favorites to restaurant. Because if we look in here, we have restaurant. So this is important. We have to declare this first, create this inside of BlueJ, this class, so this can refer to it. Because if this had a different name, I want to call it restaurant2, and we compile it, we're going to get an error. And the error is we don't know what restaurant2 is. So if we hadn't written this first, we wrote this restaurant favorites before we wrote restaurants, we're going to get a bunch of errors. So it's better to write the actual object class first than those that have access to it. So you can see here I have a set, and I have another set, and then I do a print. This is how we see a lot of objects. You can see there's not a whole lot of code that's involved with these setters and getters. So we set the restaurant's name, we set the rating, and then the get is just basically returns that particular attribute. So it's a really good idea to initialize all the variables once we declare it, so we don't have any unknowns. The best idea is to do something like we see here, where this is what we had before, but instead we just add this equals no name, so it's a kind of a dummy value. And these help us realize that if we see them, that it hasn't been initialized. And so in the code, you can see I have these values set here. Now, we can use constructors to do the same thing. So we create a constructor, and the rules for the constructor are it has to be the same name as the class, and we don't have anything except for public. We don't say like void, and we don't have any parameters in here for the default constructor. Now we can overload it and create another constructor which has a different signature. It has two parameters accepting. We could even have a third one in which we have just one parameter, for example. But remember, each constructor has to have a separate, see, it's going to give me an error because these match. So let's just say this time I only have this, and I don't know what the rating is, so I'm just going to say this is like -1. Okay, so this will compile fine because these are 3 different constructors, each with a different signature. So I could also have one that has just the init rating, and that would certainly work fine as well. So I could have 4 different constructors, which is a little bit crazy, but it's certainly possible, and I'll show you. So this will compile fine, and therefore if we have none of the information, we have both bits of information, we have one or the other, we're going to be able to initialize the attributes of this particular restaurant object. And remember, this is a generic restaurant. Remember the names that we had for example, Fave Lunch Place is an instantiation of a restaurant object. So the constructors have a set of rules. These are normally seen inside of an object. We go here and we create a default class. And you notice I just called it this. You can see I've got this df. It creates this default constructor for me, and it also creates this instance variable. Now this is a default that BlueJ provides, but you can see how these are commonly used. Of course, we'll talk more about different types of classes that we'll create. Here you've got team person, soccer team, and soccer team printer as 3 separate classes. And of course, they interact with each other. So it is important for them all to be in the same project. So we can define a main method within a programmer-defined class and create objects of that class type. So here we have basic car. So with basic car, what happens is we've got this private integer called miles driven. You can see this is the constructor because it matches the name, and it takes no parameters, and we don't even have a void here. It just sets miles driven to 0. So when this object is created, say we call, let's see, we're creating a red Corvette here. Once this is done, immediately the miles driven is set to 0 once that object's created. Then we drive a set number of miles, which we're calling down here in this main. So I create this separate statement, but we need to do this, right? We need to do and then when we run it, we get this. And we can also do something similar with the Ford Mustang. After making this change by adding these lines, I'm able to see what the output is. And all I'm doing is I'm calling this check odometer, which is going to return an int. And that's going to replace this particular position in the print line. So when I run it, I'm going to see what the odometer looks like for these cars. So again, they get into unit testing and they talk about these test benches in which you can use different methods to test the values that you get from creating these instantiated objects. This is part of regression testing, so we can check how things change within those attributes for those instantiated objects. I'm going to skip over this, but it's worth reading. We've already seen examples of constructor overloading when we talked about restaurants. This constructor, which had 0 parameters, this one had 2, this one had the first parameter, and this one had the second. All 4 of these are valid constructors. These 3 overload the first default constructor. Section 9.9 is worth looking over for that. Next, we get to references. We've already talked about pass by value and pass by reference. And how Java works with references is instead of storing the actual value of a particular object in memory, it stores a reference to that memory slot. And then there's another place in memory where it stores the object itself. This is just how Java works because objects obviously are different sizes. And the initial stack where we store this information in memory has a limited size. And it's always changing when we change scope. So having a pointer to an object is a lot more efficient for Java. I would go through this example so you can get an idea of how references work. It's important to know, and it's important to know how they're used, because when we have multiple objects, they're each going to have different references in memory. So for example, here you have 99 as a pointer inside of these memory locations, and they're both pointing to the same location. And these are references because this 99 is not the value, it's pointing to the memory location of 99. One important takeaway from this chapter is the implicit parameter called this. Now, when we're dealing with objects, it can be very confusing when we're, for example, working with a parameter that's the same name as the actual attribute. So imagine this, no pun intended, where I have side length equals side length. If I didn't make it explicit to which one is being on the left of the equal sign versus the right, it makes a big difference because if this particular attribute is here and this attribute is here, it's going to make it very confusing. We're going to set the values incorrectly. And the problem with that is if we don't do it correctly, it's not going to change this value at all. So this and this have to be the same, because otherwise, why even call this method? To distinguish this, because it's confusing, when we want to refer to the actual private field, we put this dot and then the name of the attribute that we want to set. That way, it's not confusing to somebody who's looking at this as to whether we're actually changing this value or we're changing this value we passed in. I would go through this example so you can kind of understand how this implicit parameter works. And it's quite important because you'll see it all the time in Java. Another thing we bring up are wrapper classes. So if you remember, there's reference types, which are objects, and then there's primitive types. Primitive types are char, integer, double, float. They're ones that we can store the data efficiently within the memory that Java has allocated. Other things, even strings, are considered a reference type because a string is really an array of characters. So a string has a capital S, and this is one of the reasons why. We try to set the objects as having a capital letter in their data type compared to a lowercase like we do for int, for integer. So there's ways in which we can change the primitive data types to become what we call a reference type or an object. And the way we do this is called a wrapper class. And notice they look similar, but there's a couple things to point out. The reference types have spelled out the entire name of the type. So we don't use char or int, we use character and integer. The second thing to note is it's got a capital letter as the name of the reference type. So this is what distinguishes the two different types for us when we're reading code. So one of the things about objects is it's immutable. We've already talked about arrays and how they're immutable. Strings are immutable as well. So if we want to change a particular object, for example, a string, we have to set it equal to a different string. We can't make modifications to that string without doing something to change the actual underlying object. So go through this example here. I think it's helpful because it will show you how things change when we use references as opposed to values. Remember, we are used to using relational operators with primitive data types, but we probably have run into one of these issues when we've used strings or other types of objects. When we're comparing two different object variables, and we use the double equal like we do with integers in for example, an if statement, or the not equals, what happens is instead of comparing the values of two different primitive data types, like two integers, what we're doing is we're comparing the addresses of two different objects. Even though they might hold the same value, if they're pointing to different memory locations, this is going to fail. And it's not going to fail for the reasons we expect. It's going to fail because they don't point to the same memory location. So we have to be very, very careful. We use things like compare to and equals as ways to compare strings. So this is an important way to do these kinds of comparisons. And I would go through this and make sure you understand it. So wrapper class conversions are quite frequently done. And we need to go in one direction or another direction. So sometimes we need to do autoboxing, where we're converting primitive types to the corresponding wrapper classes, which are objects, and unboxing is going the opposite direction. And sometimes we want to assign a primitive type to a wrapper class variable, and here's some examples. And sometimes we want to pass a primitive type method to a wrapper class parameter. So in this case, we have a double. I'm looking at the second one here. We are setting the rate. We have a double with a capital D, which tells me it's a wrapper class, and the name of it is rate. So if we set rate, we have a double new rate. Notice the lowercase d. And so what's happening is when we set rate to this new one, it's auto boxing new rate to become this wrapper class. So here's some of the unboxing ones. And I would go through these and make sure you understand them. If you don't, bring them up in class and we'll be more than happy to talk about them. So sometimes we want to convert wrapper classes back to the primitive data types. And here's some examples to show how that's done. Some of the ways that we've used strings are using the toString, which we're changing a numeric to an actual string value. And we can do parseInt, where we're looking through the integer. We're looking for a particular value in that integer. So you can see some of the operations we can perform. One thing I'd like to talk about is array lists. Now, later in this course, we'll talk more about types of collections, but one that's worth mentioning early is an array list. If you're familiar with Python, these are very similar to lists. Now, one of the problems with arrays is arrays are immutable, just like every other object that we've talked about. But array list is an ordered list of reference type items, and each item is called an element, just like with an array. And how we declare it is we use these angle brackets as opposed to these hard brackets like we did with arrays. So one thing is we have to declare an array list as having one of these wrapper types. It's easy to do something like this and think that we're doing things right, but we have to make sure we use the right data type, a reference type variable. One of the nice things about array lists is they're mutable, meaning we can make changes, we can append to it. There's a bunch of different operations we can use. Like every object, and we'll talk more about these when we get to collections, is we can add, we can get, if we know the index in that particular array list, we can set, which means we can change the value, and we can also determine the size of the array list. It's pretty easy to get access to things, so an array list is frequently used when we're dealing with data of a particular type because it's so useful compared to, say, an array, which is immutable. Once we've hit the size of our array, we've got to move that to another array of a larger size. With an array list, we can just add on to it. Another thing is we can iterate through with a loop through the array list because we can determine the size and we just go through. So it's very useful for when we have a bunch of elements and we're trying to get through them, much like an array, but it's just more convenient. So we can have an array list of objects. So one of the things we like about that is here you can see we're importing this library, which we need to do. So when we use an array list, we have to use Java util array list, or sometimes we just do Java util star, and it's going to bring in things like scanner. We don't have to have two separate import statements, although it's not as efficient with memory. For the purposes of us using this here, we can just bring in the whole Java util library. But again, when we declare our array list, we have to be very careful that we use the right data type. So how we define our array list is here. And notice that we're using review, which is not a primitive data type. And review is defined here. So review is this object or this collection of like attributes and methods. And we're creating an array list that's containing those types of review objects. So there's this Java collection framework that defines these interfaces and classes in Java. When we talk about collections, these are generic groups of objects. So there's hash maps, there's queues, there's trees, there's a ton of them. We'll talk about this later in the course, but list is one of them. So the nice thing about list is it's one of the items in the array list. So it allows us to have a bunch of different methods that we can use for that particular list. So here we have the ability to use a get, the set. We can check to see if it's empty. We can clear it out. We can check the size. We can add and check to see whether a value is in there and it returns a Boolean. So I would go through these methods, make sure you're familiar with add and remove and some of these others. I would go through these exercises and make sure you're comfortable with array lists, and many of you are. If you have any questions or you're still kind of struggling with a particular area of objects, feel free to contact me or bring it up in class. So if you have questions, there's probably somebody else in the class who has questions on the same topic as well. And again, we're going to skip over these block tags for the Java docs, but just realize that they exist. We have reference variables, and you can see there that they point to or refer to an object or an array. So we can have methods with wrapper class parameters. So here we have a class called adder, and you can see here We have integer, and the question for you is that a wrapper class or a primitive data type? Double and int. And what about this double here? And you should be familiar with the fact that all these wrapper classes are immutable, which means we can't change the contents after we've created them. So we have to build new objects. And this is not true about primitive data types as a result of how Java stores these. So it can be a little confusing in the beginning, but work through these participation activities and these can help. Because understanding how these user-declared reference variables work with methods is going to help open some doors for you with objects in class. Now, when we create a method, whether it be main or any other, you commonly see something like static. So we have public static void main. What static tells us is when we create a particular variable, we're only going to allocate memory for it once during the entire program's execution. So the static memory for that particular variable has a global scope. So we can access it from anywhere inside the program. So in a class, we could have a field of the class, and these static fields are independent of any object. So they're kind of like global. And the reason for that is we're able to have access to it from anywhere. So also we could have static member methods. You can see the example here of public static int getNextID, which is a static member method that's used to access and mutate. So those are the accessors and the mutators, the getters and setters. And the last is looking at different types of Java packages. Now, we talked about Java Util, there's Java Lang, there's Java IO, and there's also Java Swing, which we'll talk about when we get to some of the graphical user interface topics. So you can do things either by using the fully qualified name, or you can use the star, which is the wildcard. And this chapter talks about how these are used. So these packages are important. And that ends the discussion on chapter 9. Thank you, and I'll see you in class.